Okay, guys, so on this sheet you'll notice that the first 8 are very similar to what you just did. But if you jump down to one like number 9, okay, now we have a whole bunch of variables in here. Well, you're going to simplify them first. So, if I look at number 9, is everybody going to do number 9 with me here? Alright, this 4 on the outside, that's just going to stay there. There's nothing up top for me to reduce it with, so I'm still just going to have a 4. But now, let's simplify the square roots that I have on top and bottom. So 3/5, can I simplify that fraction?
No.
No, so I'm just going to make a square root on top and on bottom. I'm still going to have a 3 and a 5. But look at the x's. If I have x squared on top and x on the bottom, x on the top, correct. And then what happens with the y to the thirds? They cancel out, so I'm pretty much done with those. So, alright, that's not so bad. The only thing I have to take care of is the square root of 5 in the denominator. Right? So I guess I don't need these as long as I made them, but whatever. So how would I get rid of that square root of 5? Yeah, multiply by square root of 5 over square root of 5. So my numerator is now what? In the square root, right. Square root 15x. And in the denominator I have 20. Square root of 5 times square root of 5 is just 5. 5 times 4 is 20. And there's the final answer. Okay? So just be careful. Simplify first and then take care of whatever is left. So let's try 10 together. Again, that 3 on the outside, it's just going to stay there. And then let me set up my square roots on top and bottom. All right. 15 over 10 is going to reduce to be? 3 over 2. Correct. X's. Gone. Y's. You got it. Y to the second on the bottom. Okay? Now, you could multiply by 2y squared over 2y squared, but there's something I can do that's going to make my life even easier right now. Yeah, can't I take the square root of y squared?
Yes.
What is it?
Y.
Just y. So what this actually comes out to be, I have square root of 3 on the top, and then that y squared, I know the square root of y squared is just y, so this becomes 3y square root of 2. Do you see how we did that? The square root of y squared is just y, so it comes out, and now I don't have a y under there at all anymore. And this is much easier to deal with now. So the only thing I have left to do now is, yeah, square root of 2. Yep, perfect. So now up top, I just get the square root of 6. And then think for a minute what this denominator is going to be. Well, remember, it's all multiplication. Square root of 2 times square root of 2 is just 2. 2 times 3y is 6y. Yep, and is that a good final answer? Yes, that's perfect. Okay, so just because there's variables in it, just simplify them first. If any of them are perfect squares, you can take them out. Alright, so now, I told you we were going to start talking about binomials being in the denominator. Yes, we have to. And actually, before we do that, we should talk about a binomial in the numerator. Let's just look at 12 real quick. If you had a problem like 12, here's what you can't do anymore. See how the numerator is a binomial? You have this thing plus this thing. There's 2 pieces. You can no longer reduce these with each other. Oh, Miss Savia, why? You said anything in a square root, as long as they're both in the square root. You're right, but this one is married. Right? Yes. So remember, that's a whole unit. So the only way to cancel anything out is to have an identical binomial in the denominator. And I don't. So you cannot cancel pieces of a binomial with something else. Okay? So please be mindful of that. If you have a binomial, you can't just cancel pieces. You have to be able to cancel the entire thing with the entire thing. Or I have to be able to factor something out. I might be able to get something out eventually. Okay, so let's see. Yeah, maybe we should do that first. This square root of 2n squared, that can be simplified right there. Right? Because can I take the square root of n squared?
So n root 2?
Yes, so this actually turns into 3n squared plus n root 2 all over the square root of 10n.
Is that it?
No. I still have a square root in the denominator that I have to deal with. Now, I can, though, if you want to, you can factor an n out of the top. See how they both have n's? So now I could take an n out, and I'd have 3n plus the square root of 2.
Can you do that in the denominator?
What do you mean?
Like, could you just take it out of the denominator too? Or
No, because it's under a square root.
oh.
Yeah,
Wait, but you took it out of the one up top.
because that was an n squared.
Oh. Okay,
Yeah.
you're right.
So now I do have to get rid of that square root of 10n in the denominator. So let's multiply top and bottom by square root of 10n. Okay, so now here's what I get. My denominator is just 10n. That's easy. Up top, I have all this stuff going on. Woo dear. So let's see. What's our best course of action here?
To be honest, I think we should have just left the numerator alone because I think it would be easier.
I'm wondering the same.
Yeah, I think that would be better.
Alright, so let's imagine 3n squared. I would leave the n out. N root 2. If I multiplied that by that, well, maybe not.
No, it's much easier.
Alright, let's just multiply this by its original. So that would be 3n squared times the square root of 10n plus, now all this is in square root. So it'd be 20n to the third. Oh, but now I have to deal with an n to the third splitting up.
Wait, I thought it would be 30. Wait. I'm so confused.
I went back and I multiplied by the original.
So what did you get, 30 and?
No, because he's in a square root and he's not. So that's how I get 3n squared times square root of 10n. But these are both in square roots, so then I get 20n to the third. This one's awful, to be honest with you.
I still don't get how you get 20.
Because this one right here times this one right here, they're both under square roots, right? So 2 times 10 gets me the 20, and then n squared times n is n to the third.
Because you're doing 2n squared though. I thought we were doing n root 2.
Oh, I thought you wanted to go back to this one.
No.
Oh, okay.
You have to simplify.
You're right. So, all right, let's go back to this one then. Then that would be 3n squared times the square root of 10n. And then that would be n times 20, square root of 20n. So now we would factor out an n from the top. If I gave you one like this, it'd be bonus. Because this one's a beast. All over 10n. Now, do you see something I can do right here? Yes, the n's cancel with each other. And I'm almost done. It's just that 20 I can simplify. So that would become 2 root 5n. Right? Because that's split into 4 and 5. And there's my final answer. Oh, that one's awful. Sorry. I didn't mean to give you one that was so bad. All right, let me draw your attention to number 15. This time, I have a binomial in the denominator, and there's a square root down there. So, I have to get rid of that square root of 5, right? This I need everybody paying attention to. Are you with me here? Because this comes up all the time. All the time. I wish I had a pencil. Oh, I do. All right. So the most common thing that kids think that they should do is multiply by the square root of 5 over the square root of 5. Unfortunately, that's not going to work anymore. Because, watch, if I don't write this down, but if I did that, yeah, I'm still going to have a square root in the denominator. It's just going to move over here. So now if I multiply it, right, because that's I'd have to distribute, I'd get 4 root 5 plus 20. Well, I'm no better off. I still have a square root in the denominator. It didn't help me any. It just made my life more complicated. So there's got to be a way to get rid of the square root in the denominator. There is. Anybody have a...
Wait, what if you did square root of 25? Is that what you need, or?
No. What'd you say? It's not, it's a good guess, but it's the same problem's going to happen. It's just going to move it over here. The only way to get rid of a square root in the denominator when the denominator is a binomial, you ready for this? You have to multiply by what's called the conjugate. Yes, multiply by the conjugate. Conjugate. What is the conjugate? It's the same exact binomial, except you change the sign in the middle. So the sign in the middle right now is a plus. You just change it to a minus. So, yeah, check this out. So on top, I'm going to multiply by 4 minus 4 root 5. And on bottom, I'll multiply by 4 minus 4 root 5. That's still 1, isn't it? Right? It's the same thing on top and bottom. So that fraction is still 1. But when I multiply this through, you're never going to believe what happens. Okay. Up top, I have to distribute. So that gets me 12 minus 12 root 5. What was that?
I thought it would be 3 root 5.
I have to do 3 times 4 and 3 times, yeah.
Oh, yeah. Sorry, that was my...
Now, in the denominator, you have a binomial times a binomial, so don't you have to FOIL that together? Right? Right? Binomial times binomial, you have to FOIL? So watch what happens when I FOIL this. Ready? First, 4 times 4 is 16. Outsides, 4 times negative 4 root 5, negative 16 root 5, right? Right? Insides, positive 4 times positive 4 root 5 is a plus 16 root 5. And then the last, be careful, 4 times negative 4 is negative 16, and then the root 5 times root 5 is just 5, so negative 16 times 5 is 75? Is that right?
No.
16 times 5. How did I get it so bad? Yeah, that's 80. Whoops. 80. Sorry. So now when I combine like terms, what happens? Yeah, look. Check that out. Negative 16 root 5, positive 16 root 5. They cancel with each other. And then I just have to do 16 minus 80, which is negative 64. But there's no square roots anymore in the denominator. So that's how you get rid of them. You multiply by the conjugate. Now, is this a good final answer? No, because remember, you have to check. When you have something like this, you're checking for all 3 of these numbers. If they have a common factor, you have to divide by it. Yes, I can take out a 4. So that would be 3 minus 3 root 5 over 64 divided by 4 is 16. Now, it's only the sign in the middle that changes. So when you look at 16, you are going to multiply by -5 plus 3 root 3. Only the sign in the middle changes, not that one. That one stays. -5 plus 3 root 3. Remember that these are binomials, so on the top you're going to have to distribute, and on the bottom you're going to have to FOIL. Are they annoying? A little bit. But as long as you know to multiply by the conjugate, they're not so bad. And that's how you're going to get rid of those square roots, okay? So that's only when you have a binomial with a square root in it. So everybody go ahead and finish 16, and let's see if we all end up in the same place. Don't look up at my screen until you're done. Did you get the same thing I did? One thing that I just want to point out to you, if this were a test and you gave me that answer, totally fine for me. If it were multiple choice and you didn't see this answer exactly as it is, what sometimes people will do, since that's a -2, they'll divide both of these by the negative and get rid of it. So an equivalent answer to this would look like this: positive 25 minus 15 root 3 over a positive 2. They are totally the same. They just took the negative out, but you have to divide it into both things on top. All right, but these are the same exact thing. I don't care which one you give me. I just need you to be aware multiple choice could look like this instead. Yep.
Can you go over it? Because I got the numerator, but I didn't get the denominator.
Sure. So when I FOILed this denominator, -5 times -5 is a positive 25. There's first. Outsides, -5 times 3 root 3. That gets me a -15 root 3. Okay. Now I do the insides, -5 and a -3 root 3. That's now a positive 15 root 3. And then the last, so you have -3 root 3 times positive 3 root 3. So first of all, the sign's going to be negative, right? Because I have a positive times a negative. 3 times 3 is 9, and then root 3 times root 3 is just 3, right? So 9 times 3 is 27. So that's how I got a minus 27 right there. Now, the 15 root 3's will cancel each other out, and then I just have 25 minus 27. And that's how I ended up with the -2 down there. Okay. Is this so bad? Forget about number 12. Or 15, 16, okay? All right, so here's what I would like you to do this evening. I would like you to do numbers 1 through 8 on the front. And then on the back, let's just do, I want you to do 17, 18, and 19. Let's do those three.
So which one's on the front?
Front 1 through 8, on the back 17, 18, 19. I will go put this on Google Classroom. Oh, I forgot that.